Hey everyone, in today's discussion we are going to look at losses in the pipe flow. These include major and minor head loss. Why are they important? They are used in determination of the total head against which a pump has to work. Remember, a pump is always used to push these liquids through the pipe system. Now let's look at the losses that we have. There are major losses, and these are always due to friction. This can be determined by Chezy's formula or Darcy-Weisbach formula. Now, Darcy-Weisbach formula states that HF is equal to 4F times L times V squared divided by D times 2G, whereby F is the coefficient of friction of the pipe, L is the length of the pipe, V is the velocity of the liquid in the pipe, and D is the diameter of the pipe. Now, the coefficient of friction, F, is actually a function of Reynolds number. Reynolds number is a characteristic of the liquid that tells us how much viscous the fluid is, or it tells us of the magnitude of viscosity of the fluid. If R, or the Reynolds number, is less than 2000, then F is determined from F equal to 16 divided by Reynolds number. If if we find that RE, the Reynolds number, ranges from 4000 to 10 to power 6 in value, then F is equal to 0.079 divided by Reynolds number to power a quarter. Now, let's look at Chezy's formula. In Chezy's formula, we find that the head loss due to friction HF is given by F prime divided by rho G times P out of A times L times V squared. This is how it is defined, and therefore P is the weighted perimeter, A is the flow area, L is the length of the pipe. The ratio A out of P is the area of flow to weighted perimeter, and this ratio gives us what we call hydraulic radius or the hydraulic mean. The hydraulic radius, having been known as the flow area of flow divided by weighted perimeter, if it is a pipe, then we can take the area of cross section as the area of flow, which is pi d squared out of 4 divided by the weighted perimeter, which is always the cross section circumference, and this is pi d because it is this part that is circular which is weighted, and therefore getting its perimeter, of course, is the circumference. So solving this would give you d out of 4. What about if we substitute for P out of A? That means we are substituting it with 1 out of A out of P. But remember, A out of P is the hydraulic mean depth or the hydraulic radius. Therefore, P out of A would give you 1 out of M. So substituting this value in HF, which is the head loss due to friction, would give you F prime divided by rho G times 1 out of M times L times V squared. Therefore, V squared, if I make V the subject of the formula, it would become V squared equal to HF times rho G out of F prime times M divided by L. Meaning that if we simplify it or expand it further, it would give us the square root of HF divided by L times the square root of rho G out of F prime times root of M. Now, this HF is the head loss per unit length. In other words, that as you move along the pipe length, there is always a given amount of head loss. So the HF divided by L is the head loss per unit length, and would actually give you what we call the slope, I or S. We can take I. So meaning that if we substitute this value in V, Then velocity would be the square root of I times m times now the root of rho g out of f prime. Now since rho g is a constant, f prime being also a constant, then we can replace it with c, so that the v, the velocity defined by Chezy, is equal to c times the square root of mi. Therefore, it means if I'm able to determine the slope I from this formula, I can substitute it from the fact that HF out of L is equal to I, then I'll be able to get the head loss in the pipe system due to friction according to Chezy's formula. Now let's look at what minor losses are. Minor losses include the head loss due to sudden enlargement of the pipe. There is also the head loss due to sudden contraction of the pipe. These result into formation of eddies, which eddies create the void or the space within the fluid, and the occupation of these spaces by the fluid within those areas will always result into a reduced head loss, in other words, which is going to be registered as head loss due to either enlargement or contraction due to the formation of eddies in that turbulent flow of the liquid, or the formation of eddies at the turbulent regime of the flow of the liquid within the pipe at that particular section. Then we have head loss at the exit of the pipe. There is always going to be head loss due to entrance of the pipe. Then also head loss due to an obstruction in the pipe, and head loss due to bend in the pipe. Then we shall always also experience head loss due to pipe fitting. So this is all about minor losses, but also we have all looked at major losses that are due to friction. Thank you so much for watching. See you in the next lecture.